Alright, so I'm back to talk about the bell curve stuff. Number one, I said you could probably skip because I don't think that's a question you would have. That's not something we did in class. I think that's more of an Algebra 1 question. So if you needed it, you would use your calculator, you would put it in list 1, and then you'd go to stats and you would do one variable. But we didn't talk about it or practice it. So I'm pretty sure you're going to be given stuff more like this. So it says the mathematics test has 200 points on the test. The mean is 120. So remember, you have to know your bell curve, and you have to remember that the mean is that middle line, and the standard deviation is 20. So that means that it's going to go up by 20. So 140, 160, 180. And then it's going to go down by 20 is 100, 80, and 60. Alright, so then it says what percent of the students score below 100? Well, since 100 is actually on a line, then we do not have to use the z-score. We just have to remember our percents. So this one was 34. Remember, this one is 13.5. This one's 2.35. And this one is 0.15. So, since we're talking about anyone that scored below 100, that is this much. So if you add those three together, that's how you get your 16. Alright? In order to pass the mathematics pretest, a student must score 140 points. So that is right here. It's one standard deviation above. Okay, so that's passing. Alright, if 360 freshmen took the pretest last fall, how many passed? Well, I think there's a typo here, because passing means 140 or higher, which we already know if this end is 16%, we know that this is the mirror end, so it's also 16%. And 16% of 360 is not on here. So I believe that instead of saying passed, the question actually is how many failed. Okay, because what we can do is we can find 16% of 360. So 360 times 16% is 50, I think it was 58 students. So that means that 58 students actually fall into this side. Okay, 58 students actually fall into this side because that's how many passed. So that means that from here down is how many failed. So you would subtract that, and so that would be 302. And if you notice, 302 is one of our answers. So I'm pretty sure that there was just a typo. Since there isn't 58 students, then it's really, we should probably ask the other side, which is taking that 58 away from the 360. Okay? This one, this one's pretty easy. I don't think you guys need it. You just need to remember standard deviations are 4 away. Just draw it out, and I think you'll be fine. This one, again, I don't think you're going to have a question like this because you would need to know the formulas, and you need to know how to do it in your calculator. I think that's more Algebra 1. One that you would get, let's go to this, well, where is it? Alright, since we're talking about standard deviation, this is actually on the next page. It's the last problem on, for whatever reason, the probability page, where it's like you're doing combinations and permutations. But for whatever reason, this was put onto the end of that practice problem. So since we're already talking about these bell curves, let me go ahead and go through this one just to remind you of how to do that z-score stuff. Okay, so here's our curve. Here's 34%, 13, or 1 deviation, 2 deviations, 3 deviations, 1, 2, and 3. Okay, so it has a standard deviation of 11. So we know that it's 11 away, plus 11, plus 11, plus 11, minus 11, minus 11, minus 11. And the mean is 108, so that's 108 is in the middle, so that means that if you add 11, that's 119. If you add 11, that's 130 and 141. If you take away 11, let me see if I have, my brain's just thought about this so much, I'm tired. Alright, so Oh, I didn't even bother with this side because of the question, but take away 10 is 98, take away one more, so that's 97, take away 10 is 86 is 11, and 75. Okay, so that's really the way the curve sets up, but if you notice, the question is asking about 125, and unfortunately, 125 does not fall on a line. It falls in between those two deviations. So instead of using the percents, this is where our z-score comes in. So remember, you just turn to the formula for z-score. So it is x minus the mu over the standard deviation. So the x that we're looking at is 125 minus the mean, which is 108, over the standard deviation, which is 11. So I'm just substituting all of those in. And I get a decimal of 1.55 if I round correctly. And then remember, this is where you use your formula sheet. Here it is right here. Use your formula sheet. 1.55 is on this side. Go over to 55 and you get 0.9394. Well, remember, this represents the left side of your graph, okay? And if you forget that, it actually shows it. It's the left side. It's shaded left. So, but we need to see, what is it asking? It says, which is closest to the number of values expected to be above. So it's actually not asking about the left side, it is actually asking about the right side. So in order to get this side of the graph, just take one away from it. And so we actually get 0.0606. So 6.06% lie here, but we need to find that percent of 968. And so remember, we just multiply 968 by that 0.0606, because that's the percent, and we get 59. Okay, we get 59 kids, which makes sense because that's not a very big percent. So 968 students, that's almost 1,000 students, and we're only looking for 6%. So that's why it's only about 60 kids or 59 students. Okay, so that is the standard deviation. So the last thing we have are permutations and combinations. So, some of these are easier than they appear. Even when I do them, they're easier than they appear. So, this one's pretty easy. I don't think people had questions on this. If digits can't be repeated, how many 3-digit numbers can be formed using the digits 1, 2, 3, and 4? Okay? So this one I just used permutations. So let's look, although it does say that they can be repeated, so if the digits can be repeated, how many 3-digit numbers can be formed using... Alright, so actually that means that if we've got 3 digits, 1, 2, and 3, then that means each one has 4 options. 4, 3, 2, or 1. 4, 3, 2, or 1. 4, 3, 2, or 1. So actually we don't have to use a permutation choice. We can actually, because it says they can be repeated. So if I have 4 here, I could have 4 here and it'd be fine. If I have 2 here and I have 2 here, so you're not just picking them out and leaving them. They're actually independent of one another. So 4 times 4 times 4 is really just 64, okay? And I think I may have made that a typo on your answer key because I was making it more complicated with permutations. So since they can repeat, they're independent of one another. So it's just 4 options here, 4 options here, and 4 options here. All right? It kind of seems the same with this one. Well, it says permutations, and it says how many permutations can be formed using these letters. So, how many different ways can I rearrange this? So, how many letters do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. So, we're going to start off with saying 11 factorial. Okay? Now, this is a little bit different than just the permutations formula we've used because there is repetition in here. There are 2 M's. So we actually divide that by a 2 factorial because they repeat. So the first m is no different than the second m in there. Okay, there's also 2 a's. So that's another 2 factorial that we divide by because that compensates for those. And then there's actually 2 t's. So for everything that we have repeating, like if there were 3 t's, we put 3 factorial. If there were 6 a's, we put 6 factorial. So this stands for the repeating m's, the repeating a's, and the repeating t's. And then when you put all of that into the calculator, don't forget that there should be a parenthesis around the denominator, but when you do that, you get a number, but it's not quite as large as other ones I was getting. 4,989,600. Okay, so that is different than just the permutation combinations formulas we've been doing, but that's probably why it was a little bit trickier to try and figure out, because it was trickier for me too until I looked through it and looked at how to deal with the letters and that kind of stuff. All right, here, again, they are independent of each other, just like this one. So it says if numbers and letters can be repeated, they're independent of one another. How many 6-digit license plates? So 6, let me do it up here. 1, 2, 3, 4, 5, 6. Okay. If the first 2 positions are letters, so how many letters do we have to choose from? 26 for the first 2, and the last 4 are digits. Well, when it comes to single digits, we have 1 through 9 and then 0 as well. So that's actually 10 digits that we can choose from for each of those. It doesn't matter if they repeat, so that's why we're looking at them separately. The only time we would use permutations and combinations is if when we got 1, we couldn't use it, and that's why you'd use those formulas. So really, all you do is multiply these up. And so that's where we get, I believe it's H, it's way down here, 6 million. Just be careful with the zeros, that you don't drop one of them. Because this answer looks really similar, except we don't drop it. Okay? All right. The rest of it is just a bunch of review from these. So what I would do is I would just look for patterns. I would use the formulas. Hopefully some of these things that I've clarified with repeating letters, or if they're independent compared to using permutations and combinations, gives you a little bit of a heads up. Let me see. On this last page, I did skip a little bit. All right, on this last page, before you get to the overall review of it, there are a few combination and permutation problems. Hopefully, I think this is what you're going to be more likely to see on your SOL test. So it says, okay, now it's separated into 2 parts, okay? That's teachers and it's students. So when it comes to the teachers and the students, okay, so we're going to multiply that. So, and it doesn't talk about any specific positions or anything. So 3 teachers, 3 students. There are 7 students to choose from. So since there's no order, we're not picky, we're going to use the combination. And we've got 7 students and 3 are going to be chosen. We're going to multiply that to the teachers, which there's 5 teachers and 3 are going to be chosen. Okay, so we're going to use combination because the order is not picky. I can choose any 3 students, and doesn't matter who is chosen when. All right, and then we would just use our formula from here. So it would be 5 factorial over 3 factorial times the difference of those, which is 2 factorial. And then you would multiply that by 7 factorial over. We're choosing 3, and then we multiply it by the difference, which is 4. Again, the biggest thing, be careful with your calculator. Put those parentheses around. And when I did all of that in my calculator, I got 350. I got 35 here, 10 here. Oh, excuse me, backwards. 35 here, 10 here. So that's 350 total. Okay? Number 6, order doesn't matter. Co-captain is a co-captain. It's not like a captain and co-captain. So you would use C for that one. And then we already talked about the last problem because that had to do with the bell curve. So the last couple of pages is just an overall review of all of these. Just a lot more practice on this statistics stuff. So hopefully you can go back to these other sheets, look for patterns, use the formulas, direct inverse, summation, bell, z-score, all of that stuff. But hopefully that set you up to try the rest of them on your own. There are a couple typos that I'll fix on my answer sheet when I tweet it back out. But I think from here, you should be fine. Just use the answers and go back to these problems that I've explained and apply them to maybe another one that you might not, that you might have a question on. And hopefully we're squared away for the statistics for now.